Hello everyone. In today's video, we are going to solve a problem from LeetCode, remove method from projects from LeetCode weekly contest 418. I hope you have already read the problem statement and I will break down the problem statement for you. So in this problem, we are given n nodes and which is numbered from 0 to n minus 1, and these node might invoke one another. So this information is given as a list of invocations. Uh, we can see here node 1 is invoking 2, node 0 is invoking 1, and node 3 is invoking 2. But there is a bug in node K, and it affects the node as well as any other node that is directly or indirectly invoked. And we need to remove this suspicious node. As we can see here, there is a bug at node K, and along with any method invoked by it, either directly or indirectly, we consider them as suspicious. But we can only remove this entire group if no external node means a node that are not suspicious, invoke any of the suspicious node. If even one external node calls a suspicious node, we cannot remove any of the suspicious node. So let us understand this by two example we are given. So I've already taken the example. So this is let us understand this example first. So in the second example, node 1 is node 1 invokes 2, node 0 invokes 2, and node 0 invokes 1. So all three become suspicious. But there is no contact of this suspicious node with this non-suspicious node. Currently, this is non-suspicious. So, so in this question, our answer will be 3 and 4, because 3 and 4 are basically non-suspicious. But in the first example, node 1 invokes 2, but there is a cache. Here ideally you should return 3 and 0, because 3 and 0 are not invoked by any of the node, because they are non-suspicious. But we will return 1 and 2 as well, because 1 and 2 is getting invoked by 1 and 2 is getting invoked by other external node which is non-suspicious. As we can see here, 2 is getting invoked by 3, 1 is getting invoked by 0. So 1 and 2 are suspicious previously, but uh, as 3 is the external node which is invoking 2, so we have to return 1, 2, 3 and 4 here. This will be our answer. Even one external node calls a suspicious node, we cannot remove any of the suspicious node. As we can see here, 0 is the external node, and it invoke a it invokes a suspicious node. So we cannot remove any of the suspicious node, so we are not removing 1 and 2 here. But here 1, 2 and 0 are being removed, because there is no contact of this suspicious node externally from any other external node. There are only two cases. uh, Either node starting from K gets invoked by any external node, or it does not get invoked by any external node. There are only two cases. If it does not get invoked, then our answer is pretty simple, and if it is getting invoked, then we have to think of some other solution. So our challenge is to figure out which methods are directly or indirectly invoked by K. But more importantly, we need to ensure that no outside method, in this case it's 3 and 0, invokes a suspicious method. If that happens, we can't safely remove the suspicious methods. To tackle this, we need to answer two important questions. So the first question is, which methods are suspicious? So we can easily answer this question by doing a DFS from K. Suppose we are given in this K equals to 1 here. So if we do DFS from K, we can easily find out that from 1 we can reach 2 by doing DFS. So 1 and 2 are suspicious. But our second question is, are any external method invoking suspicious method? So as we can see here, 3 is invoking 2 and 0 is invoking here 1. So to answer this, we need to consider all invocation regarding of their direction, which means thinking of a graph as undirected. So as we can see in the example, we can easily find that 2 is suspicious using DFS from 1. But the second question is, how do we know whether 2 or 1 is getting invoked by any external node? So what if there is an imaginary node from 2 to 3? Suppose what if there is an imaginary node from 2 to 3, and there is also an imaginary node from 1 to 0. Yeah. So we can easily find out that yeah, 2 is also getting invoked by someone. If there would have been a node from 2 to 3, then we can easily find out that yeah, 2 is getting invoked by someone externally. Here comes directed graph as well as undirected graph in the picture. So the directed graph represents the actual invocation. As we can see here, 1 is getting invoked, 2 is getting invoked by 1. So directed graph is representing the actual invocation. So here comes two things. First is directed graph, which we need to figure out which methods are suspicious. Figure out which method are suspicious, and the second one is undirected graph, and we need this graph to detect if there is an external node or method getting invoked. External node invoking any suspicious node. So this is what all we have to do in this problem. We can also take this example and we can see if there would have been a directed edge, the if we do DFS from directed graph, we can reach 1 and 2. But from undirected graph, we can reach 1, 2, 3 as well as 4. From directed graph, if we are doing DFS from 1, we are reaching 1 and 2, and from undirected graph, if we are doing DFS from 1, we are reaching 1, 2, 3 and 4. So basically, if the set of method reached by DFS in the directed graph as well as undirected graph is same, that means there are no outside method that can reach the suspicious method. As we can see in this example, if we copy this from directed graph, we can reach 0, 1 and 2, but from undirected graph, also we can reach 0, 1 and 2. There is no way we can reach 3 and 4 even if the edge are directed or undirected. Even if I draw edge like this, and yeah, so even if the edges are directed as well as indirected, we are getting we are able to reach 0, 1 and 2 only from undirected graph as well as from directed graph. So the problem boils down to if the set of methods reached by DFS in the directed graph is exactly the same as the set of method reached by undirected graph, it means there are no external method that will invoke the suspicious method, and otherwise there is some external method which is invoking our suspicious method, and in that case we will return all the node, and in this case we will return only those node which are suspicious. So let us look at the code of this problem. I'm doing just what I've explained. I have taken two array of vectors. First array of vector is storing the undirected edge, and second is storing the directed edge. As we can see here, we are pushing the edge bidirectional here, but we are pushing the edge directional here. So this is the undirected graph we are making, and this is the directed graph we are making. Also, I have done DFS two times. First, DFS is storing the edge we can visit uh, by our undirected edge, and second DFS is storing the node we can reach by directed edge. So if the set of node reached by DFS is same, then we will only add the suspicious node to our answer, and otherwise we will add all the other nodes to our answer, and we will return answer here. I hope you found this video helpful. If you have any questions or any doubts, please leave a comment below. And thanks for watching. See you in the next video. Thank you.